Alright, so here is the ideal gas law. It works for ideal gases, but we're going to use it for any gas. The equation is as written. PV equals nRT. P stands for pressure, which has to be in atmosphere. V stands for volume, which has to be in liters. N stands for moles, which is the amount of gas. And T stands for temperature in Kelvin. And R is a constant, and it's going to be the same constant for every problem that we do. And it is 0.0821. And the units are liter times atmosphere over mole times Kelvin. But R will never change. So that's our equation for ideal gas law. What we're going to do is look at a couple examples. On the first worksheet, we're going to look at the first two up here. So, the first thing we're going to do is identify the variables that we have. 2.20 liters, that is a volume. We're looking for moles, so that is N. We don't know that. 755 millimeters, that is a pressure. And 37 degrees Celsius is a temperature. So we're going to identify our variables. Then we're going to set up our equation. I'll just rewrite it. PV equals nRT. What I like to do with this particular gas law is if we're solving for N, which we are in this case, I want to isolate N. So get N by itself. To get N by itself, we would divide both sides by RT. So let me rewrite that so it looks a little bit better. But N would equal PV divided by RT. Then we want to make sure that we have everything in the right units. Pressure has to be in atmospheres, and right now our pressure is in millimeters. So to get our pressure to atmospheres, what we're going to do, kind of do a little conversion over here, 775 millimeters. We're going to go from millimeters back to atmospheres. In 1 atmosphere, there are 760 millimeters. So let me calculate that real quick. And to do sig figs, we start with 3 sig figs, so my answer should be 3 sig figs 1.02 atmospheres. So I converted my pressure to ATM. So let's go back to the equation. Pressure 1.02. Go ahead and write your units in the problem. That's P. Volume has to be in liters. That's what the equation calls for. And my volume was already in liters, 2.20. R is the gas constant, and we're just going to write 0.0821. And the units behind R are liter times atmosphere over mole times Kelvin. Temperature has to be in Kelvin, so add 273 to the degrees Celsius. So my temperature is 310. All right, if you look at the units behind R, what's going to happen is everything should cancel out except what I'm looking for. So, for instance, atmospheres is on the top here, and atmospheres is on the bottom here, so ATM cancels out. Liters on the top and on the bottom cancels out. Kelvin, it's in the bottom, but it's also in the denominator of the denominator, so those do cancel out. So the only thing we have left is moles. Well, moles is actually in the denominator of the denominator, so it's actually flipped up in the numerator. So that is the unit that I'm looking for. Let's do the calculation. And as far as sig figs, this has 3, this has 3. This is an exact number, so we're not really going to worry about that one. This one has 3 also if I'm going off of the 37.0 up here at the top. So my answer should have 3 because this has 3, this has 3, this has 3. My answer in moles is 0.0882. So we can use the ideal gas law for any gas. In this case, we were using it for air. As long as we're not at extreme values of temperature and pressure, we can use the ideal gas law, even though it's called the ideal gas law. Let's look at number 2. Very similar type of problem. We got a volume right here, 6.5 liters. We got a temperature right here. And we got a pressure right here. Now in this case, we're looking for grams. Grams is not moles. But we can get 2 grams from moles. So we're going to use, again, this same exact equation. And I know we're looking for grams. Grams is the mass, obviously. But in order to get grams, the first thing we have to solve for is moles. So we're going to solve for moles again first. So we're going to rearrange our equation just like we did on number 1. Use the same exact equation. And make sure our units are correct when we put these in. Pressure, again, has to be in atmospheres. And again, we're in millimeters. So I'll do that conversion in my calculator, but it would be best to show that calculation as well. You just divide by 760. And this value actually has, if we go back over here, it has 4 sig figs. So we're going to keep 4 sig figs for the pressure. Once we convert it to ATM. So I took this pressure, I divided by 760. That's where I got this value. Volume. Volume is 6.5 milliliters. In order to convert that to liters, you divide by 1,000. There are 1,000 milliliters in a liter. So when we divide by 1,000, here's my new volume. Okay, R. R is the gas constant, 0.0821. Liter atmosphere mole Kelvin. And temperature. When we add 273, we get this value. So the big thing with the ideal gas law is to make sure that your units agree with the units for R. Make sure that we have liters, atmospheres, moles, and Kelvin. Alright, this is a really small value. I'll keep the zeros in there just to show you. 0.000. As far as sig figs, this pressure has 4. This volume has 3. This temperature has 3. So my answer should have 3 sig figs. So that will be this many moles of helium. That's not what the question asked, though. It asked for grams, but that's a really simple conversion. If I know moles, I can get to grams really simply. All I need is the molar mass of helium. And the molar mass of helium is 4.00 off the periodic table. So that's a straightforward, simple conversion. Take your moles and multiply by 4 grams. Again, when we do the molar mass, we always carry it out to 2 decimal places, 4.00. So when I multiply those together, I will get that many grams of helium. So that's really what we're looking for the ideal gas law. Again, PV equals nRT. It's a good idea, whatever you're solving for, to rearrange the equation. I'll do one more where I rearrange number 3. We're looking for volume. There's our equation, but I always like to rearrange these first. So if I'm solving for volume, divide both sides by pressure. And so my equation for number 3, without working out all the math, when I rearrange it, it will look like this. Volume equals nRT over P. So I like to rearrange those equations before I plug in values. And then again, just make sure your units agree with the units for R. Make sure these are our units right here.